Hey everyone, we're back with transportation problems again. I want to show you guys a few things that we missed and go through one more example. First thing I forgot to show you in the last video, I copy and pasted these unit costs down. What I forgot to do was show you the index function. The index function is a nifty little function in Excel, and what the index function does is say, give me an array or matrix that's full of rows and columns. So you'll see I've selected all of these up here. I have 3 rows and 3 columns. Then it takes 2 values, either the row or the row and or the column value. So here I've said look in row 1, column 1, and pull that value, match it here. You'll see this matches all the way down. Look in row 1, column 4, pull that value down here. This is a quick and easy way to move my data down so I don't have to copy and paste it. Okay. So we do have our Midwest Electric here. We want to make an extension to this and say, well, there have recently been negotiations between some folks in some towns. The towns have agreed that they are willing to not have their demand fully met. Okay? This happened in California years ago with rolling brownouts. In addition, there is a penalty for every kilowatt of electricity not provided of either 20, 25, 22, and 35, right? So we're willing to suffer some pain as long as you accommodate us financially. So what I'm going to do, I'm going to go back to our original model. I'm going to go ahead and copy this over. Okay, we're going to slide this down. We're going to zoom in a little bit so you can see everything quite well. Okay. And then we are going to modify this just a little bit. So the first thing we know is that we now have a penalty. And I'm going to separate this out just so it works well. Looks good. Unmet demand. The penalty for unmet demand is 20, 25, 22, or $35 per unit. So we are going to go ahead, change that into dollar signs. We're going to go ahead and format our cells, give it some nice, brilliant fill with a nice blue border. Good. Okay, so we need something to multiply this with. So we have to figure out how do we integrate this unmet demand. So I'm going to show you something that may feel just a little tricky, but it's a very clean way to do this. What I'm going to do is say we have demand. We also have unmet demand now. And this is going to be a second set of variables or decision cells. So let's go ahead and outline those in red. Yes, you can have more than one section of decision cells. So this is a nice thing. So I have my next section here. Okay. So this is the amount received. This is my demand unmet. And then I'm going to do a total, which adds up both the amount that I have received and the unmet amount of demand. Okay? So that gives me this nice row here. Again, you'll see my formatting has gotten off here, so we're going to go ahead and make this all in the same format. That's going to happen to you. It was looking at this first cell, so I'm going to go ahead and just merge and center that across a bunch of stuff. Auto formatting ignores merged and center cells. So what we've done, we added a second set of decision cells or decision variables. We now have a different total up here, and it's now going to be that total that has to be greater than or equal than my demand. So a very, very small change that we can integrate very easily in here. It does change the way that we integrate this whole thing in the solver. We'll make sure, so see, this is all screwed up because I didn't enter it properly the first time. So we're going to cut and paste this up here so it's closer and it looks nice. Let's make sure everything is right. Okay. But this is now a little different, right? So we now have a shipping cost. We also have a penalty cost, right? And this again is a sum product, our good old friend, of how our amount of unmet demand with the penalty. Okay. That is also going to be dollars. And then we're going to have our total cost, which is just the sum of these two. Now that is going to say, well, hey, we need to get rid of this and clear the border here because that's no longer our objective. Our new objective is this. Put that nice double line around it. And we are now good to go. So let's go back into our solver. We will just reset this all, make life a little easier. We are minimizing that by changing cells. Now there's 2 ways to do this. One is to do that. Add a comma, and then pick your second set. Okay? The way that's much easier actually is to hold down your command key And you'll see when I hold down the command key, it's added both sets of cells in there. I can then add my constraints. This is greater than or equal to this. And also these, the amount used is less than or equal to the supply. Add that in there, simplex LP, and let's see what solver can do here. There we go. So you'll see in this case, we're not really missing much. We'd have to change some of these values. So to show you how this does work, we're just going to increase Rapid City to 40. We'll go into solver, solve it one more time. And you'll see we now have some unmet demand, 10 million kilowatt hours there. And that is great. Okay, so you can also do this with the alternate formulation. You can add this extra constraint in there. At every one, you'll see we have this unmet demand. You would just add in unmet demand. Well, actually, you wouldn't add it in here. You'd have to make the modifications a little more deeply to add an unmet demand in at each destination. I'm going to leave that as an exercise for you to solve and see what you can come up with. So we do have one other example that I want you to show. I'm not going to walk you through this entire thing. There's a couple different formulations here, but this is red brand tomatoes. I wanted to keep this video short, so a lot of this is already in place, but what I want you to see is just sort of how nitpicky we can get about building models. So you see Red Brand Tomato is a national chain of tomato producers. They have 3 packing plants, 2 warehouses, and 2 customers. Currently, each plant has a supply of 200, 300, and 100 bushels of tomatoes, respectively. Each of their 2 customers has a demand of 4 or 180 bushels. Warehouses may store no product, and this is a very important thing. They don't want anything rotting on the vine. Given the cost below, can you formulate a minimum cost network flow or transportation model? Okay, so this MCNF right here, minimum cost network flow, this is the same thing as a transportation model, and I alluded to that in the last video. So you'll see we've moved all this in here. We have 3 plants. We have warehouses 1 and 2 and customers 1 and 2. We have multiple plants, warehouses, and customers. We've actually gone ahead and we have, oops, let me get out of here, what I did. Okay, we're going to do this again to get rid of this issue. Right? You'll notice that we have costs for shipping a bushel from a plant to different plants. We have some routes we can take, right? So a plant can't ship to itself. Warehouses can't ship back to plants here, right? But warehouse 1 can ship to warehouse 2. Warehouse 2 can ship to warehouse 1. Customers, right, can ship to customer 2, right? Customer 2 can ship to customer 1. The warehouse can go to both our customers. We can ship a plant to customer directly. We do have the shipment capacity that we cannot ship more than 200 units on anything. And so this is exactly what we actually did in the last thing. We have all these froms and tos. Over here, I've just merged and centered my cells, so I go from node 1 to 2, 3, 4, 5, 6, 7. Note I've excluded 1 to 1 because that's not a route we can take. I can go from 2 to 1, 3, 4, 5, 6, 7. I can go from 3 to 1, 2, 4, 5, 6, 7, so on and so forth. I've also used the index function up here. One thing you will see is it actually says cost matrix in there instead of giving cells. One thing you can do in Excel if you want to make your life easier is use named ranges. So you'll see if I do that, up in this little box it says cost matrix. I can type in whatever name that I want there, and then I can use it as a reference in our formulas. Sometimes this is helpful, sometimes it is not. Some people love it, some people hate it. You get to pick and choose. So I have my froms and my tos all set up. I have all my shipment costs set up by index. I have my decision variables, which are flows. And I have my capacity constraint, right? I can ship no more than 200 on any one of these because that's the size of my truck, right? So this is a good thing in here. And we are rolling through. We have our outflow, right? You'll see sum if. And I've used more named ranges in here. My origins, right, from is equal to 1, right? Sum up my flows. Okay. Now you will see here we are looking at net outflow has to be less than supply. So what I am looking at is if I take a look at my origins, I'm summing that up, I'm subtracting everything that comes in as well. Why? Because I don't want to be stuck. I can only send out as much as I bring in. So if somebody ships something to me, it increases what I have. So I have to take care of that. So my net outflow is how much I have minus, how much I have minus how much I receive, which has to be less than or equal to my supply. I also have net inflow. Okay? Net inflow. So node 6 and 7, this is where I'm worried about demand being met. You'll see how some of my destinations are I-32, right? 6. So anybody shipping into 6 minus how much 6 sends out has to be greater than or equal to demand. Why? I want my customer to end up with everything they want. Well, how much do they want? They want 400. They have this demand. And how much will they have on hand? Well, they'll have everything they receive minus everything they send away. Okay, this is the same concept about here. Well, what can I send away? Right? My supply, right? What do I have available? Well, it's my net outflow. What I send out minus what I bring in. Okay? So we are all in good shape here. Now, the interesting thing is that warehouses may store no product, so I have this interesting net flow constraint in the middle. Okay? Where I say the same thing as I said down here, right? The amount out, or amount in minus the amount out must equal 0. That means I want to end up with 0 products stored at my warehouse. The amount in minus the amount out gives me a total of 0 stored at my warehouse. Okay? So this is a little bit larger of a formulation for a problem. You'll see the costs are the same, but the really tricky thing over here is this, right? That is the tricky thing. Why did I formulate it this way and not using a matrix of decision cells? Well, you'll see all these little black spots in here that couldn't be decision cells. So if I were to do the matrix version, and you very well can, but the whole sum product thing that we've been using does not work very well. So if I came over here, what you would see is I would have to do this. I would select all these cells that have prices in them. I would go in here. I would take away their fill. I would give them a nice red border, make it a little thicker. And that's really what we're left with in there, right? So this is not really what we want for the most part, right? And you'll see even the formatting to get this to look right, it is not the most fun thing to do because you got to take out all these middle bars so it doesn't look ridiculous. And we can do this. We can spend our time and we can make this all happen. And we can come in here and we can take away that middle bar. Take away that little bar I missed up here. Okay, but now all my formulas are going to be real wonky because I can't just select a square region and do a sum product. So this is actually really quite difficult to work with. And it's not something that I want to do. Using this, actually, the formulation I've used makes everything much easier to work with. It makes things a lot cleaner. I do just want to stress here, right? So net outflow, right? This net inflow and outflow thing when you're shipping back and forth is really important. Well, why? So look at this. Sum if my origin is equal to I-21. So this is the amount I'm shipping out. The amount out minus the amount in, right? So the amount out minus the amount in has to be less than or equal to my current supply, okay? The amount in minus the amount out has to be greater than or equal to my demand, and here they have to be equal, right? And you could actually slide this over and take this second half of the formula, make it positive and put it in the constraint, but it's just not as clean. Using this as a 0 works really well. So this is a more advanced formulation for red brand tomatoes. You're going to have to spend some time with this and work through it, particularly these node flow constraints.